Yes, Assalamualaikum warahmatullahi wabarakatuh, and a very good um, morning. Yes, good morning. So today we will continue our class, our tutorial class. I have provide some sample of questions, okay, for us to try to answer this question together. Okay, so we try to go to question number one. All right. A researcher is interested in whether there is a relationship between daily temperature and the amount of students that students study. He measures the temperature each day for 6 months, and the mean number of hours spent in the library by the group students. What test is required to test the hypothesis that study time is related to the temperature? Okay, so the question asks for um, what test? Okay, what test do you use to test this hypothesis? Okay, the clue is here. Okay, researcher wants to study the relationship. Okay? Relationship between the daily temperature and the amount of the time that students study. All right. So from here, there's no any other requirement other than the relationship that would give uh, a clue for us that we need to use what kind of test, okay, what kind of analysis for this kind of situations, right? So if you can recall by yourself, for relationship, usually we use what test? Pearson correlation test. So you just write Pearson correlation. Okay, so this is the answer for the first questions. Okay, very straightforward. The question is very straightforward that what kind of test? Okay, they gave you a situation, and then from the situation you need to um, try to sort out what kind of clue that has been given. So the clue is from the relationship itself. Relationship between what variable with what variables, and very straightforward, no other requirements. And the test is Pearson correlation. Okay, very simple. That is how you try to tackle the questions, okay, by looking at the what is the key words, okay, what is the keywords that has been given. So next question, okay, they ask you to state the hypothesis. Okay, when they say hypothesis, whether it is null or alternative. Okay, but you can see it is plural, meaning you need to mention both null and alternative hypothesis. Okay, so you need to do your null and alternative hypothesis. It is not as hard as you think. Okay, try to further read the questions. You are trying to find out the relationship between the IQ score and height for one of the sample. Okay, so the first variable here is given IQ. Okay, the second variable that has been given is height. All right, and then the test that has been used is Pearson correlation, meaning from here is the what we call a hint. Okay, it is a hint what kind of terms that you need to use for Pearson correlation. Of course, you are looking for the relationship. Okay, relationship between IV and DV. So how to answer this kind of question? First, try to recall back. Okay, try to recall for null hypothesis. Okay, the overview of how to write the null hypothesis. Okay, so usually for the null hypothesis, if you are looking for looking for the relationship, okay, using Pearson correlation, relationship between IV and DV. So the way that you need to write is there is no, okay, no relationship or no correlation can, okay, no correlation between, okay, IQ score, because here you will be given with the score, IQ score and height of height in the population, sorry, height in the population. Okay, so this is the null hypothesis. How about the alternative hypothesis? Alternative hypothesis is the one that you need to against your null hypothesis. So if your null hypothesis is saying there is no correlation, so your alternative should be there is a correlation. Okay, correlation between IQ score and height in the population. Oops, population. Right? So this is your null hypothesis and this is your alternative hypothesis. You have write the null and alternative hypothesis based on here. Okay, why you use the term correlation or relationship? Because hint here is the test need to be used by using Pearson correlation. Okay, next. Okay, next question is here is given tables. Okay, tables from what for what? The ANOVA table. Okay, the ANOVA table and also the coefficient table. Okay, so this both of this table are obtained from SPSS analysis. Okay, this is not from mine data. This is the question that already given to you. Okay, might be your final exam look like this. They will give you a table, okay, and then from the table, this is a SPSS analysis table, the output. Okay, so from the table, they ask you to solve the question. Okay, so it's the first table, second table, both are from the SPSS output. Okay, so they ask you to answer some questions lah. So the first one, okay, the first question here, one researcher collected the information on the relationship among Y annual salary, X1, H and X2 total hour working daily. Okay, you know that if you still remember the analysis that use the terms of relationship, either it is correlation, okay, Pearson correlation or regression, if you still remember. Okay, but the hint is here. Okay, they already state here in the table you have the regression. Even if they don't state the regression here, the way that this table the layout for this table, you know this is the interface output for the regression. Okay, if you still remember for the beta, if there's a beta value, okay, and we have the ANOVA and the coefficient table. This is the not outliers. This is the interface output for data analysis for regression. Okay, so okay, you have confirmed that this analysis is using linear regression. Okay, but which linear regression that we should use? Is it simple? Is it multiple? Okay, if you still remember, if we have more than, okay, more than one IV, we need to use multiple linear regression. Okay, because here you have more than one IV. This is your predictor or the IV, independent variable, age and hour. So you have two IVs and if you still remember, more than one IV, okay, which is two or more, you need to use multiple linear regression. So the answer here is multiple linear regression. Okay, why? Because the question asks you based on the SPSS output in the table, state the regression model. Even the question asks give you the hint regression model. If the question didn't give you the hint, state the model. So you don't know which one is it, regression, is it Pearson correlation. So it depends on here the hint, the beta value here, the regression written here. Okay, so that is the hint. So the answer for the first one is multiple linear regression. All right, next, interpret the b value as stated in the regression model. Okay, so the question asks you to interpret the b here is beta. Interpret the beta value as stated in the regression model. So if you can go back to the table, the beta value is here. Okay, the beta value is here. So how to answer this kind of question? I have give you the outlines. Okay, the first one you need to talk about the first IV or the first predictor, which is age. Okay, and it is stated as x1. Second one, you need to talk about the hours, the second IV, and it is stated as x2. All right. Now, allow me to change the color for this. All right, this marker. So you need to talk about the age first, okay, which is I have stated as x1. All right. So the b or the beta value, okay, the beta value for the age, if you refer to the table here, okay, the beta value for the age is 13.35. Okay, it means that for one unit, okay, for one unit increase in age, okay, the predicted value of the salary, because the salary is the DV, okay, one unit increase by the age, okay, will predict the value of salary, and it is expected to increase by 13.35 units. Okay, that is what how you read this value for the beta value in the table. Okay, however, it is important to note that the p value, okay, the p value is here 0.107. So this p value here is more than 0.05. Okay, more than 0.05. So what does it means? It means that the coefficient of the age, or the age here, okay, age variables is insignificant. Okay, insignificant. Why? Because if it is more than 0.05, means you fail to reject your null hypothesis. So you need to state that the age is there is no correlation. Okay, no correlation between the age, okay, and the salary. Okay, so you have insufficient evidence to conclude that the age is significant or the age will give the effect. Okay, you have insufficient evidence. All right, so that is for the first one, the age. Okay, so how to write the result is that I think this one I need to write. Okay, I need to write I need to type. Okay, I need to type because if I write, you cannot read my handwriting. Okay. All right. So I need to type the the beta. B is beta. The beta value for the H is how much just now? Is 13.350. Okay. So this means that for a 1 unit increase in age, it would predict. Okay, sorry for the incorrect grammar. This is what has been pop up in my head. I try to uh, make it formal. Okay, and then I try to rewrite for you in Microsoft Words. All right, it would predict value of salary which expected to increase by 13.350. So we have talked about the significant value. Okay, we have talked about the significant value as well, which is P is less than 0.05. All right, so however, it is important to note that the p value uh, the p value for of sorry, that associated with the h variable is 0.107. Okay, 0.107, this one. Okay, so continue. 0.107. Okay, in which p is more than 0.05. Okay, so from here we can see that this suggests that the h variable is insignificant. Okay, and there is an insufficient evidence to conclude that the H has insufficient evidence to conclude that the H has a significant effect on the salary, okay, or the salary. Okay, so why is this being bold? All right. Okay, so this is the suggested one. Okay, oops. So this is, oops, what happened? So this is the suggested one. All right. Okay. So this is for the first IV, the first independent variable. Okay, you are talking about the first independent variable for the B values. Okay, you need to state both H and hour. So you have done with H, then you go with hours. Okay, so hours is denoted as x2. Okay, hours is denoted as x2. So it is the same thing. It is the same procedure that you need to look at okay, that you need to look at the value of beta, okay, about 243.714, okay. So this is the beta value for hours, all right. So it means that the same thing, it means that 1 unit increase in hours, okay, 1 unit increase in working hours, it depends on you, okay. 1 unit increase in working hours, the predicted value of salary is expected to increase by 243.714 units, okay. The same like this one, but the difference is the value for the beta, okay. So what else that you need to look at? You need to look at the significant value, 0.002 here, okay. The p value, okay, the p value that associated with the working hours variable is 0.002, which the p value is less than 0.05. If your p value is less than 0.05, your null hypothesis need to be rejected. So meaning that there is a relationship, okay, between the working hours with the salary, right? So it indicates what? It indicates that the hours variable here, okay, is significant, okay, is significant, and there is an evidence, okay, to support or to suggest that hours, working hours have a significant effect on the salary. So how to write that? How to write that? We go to the hours here, all right? Okay. So here you need to the value of the beta value lah. The beta value, B is beta. I cannot do the the symbol for beta here. The B value for hours, okay, hours variable is 243 just now, 243.714 if I'm not mistaken, 714. Okay, so this means what? This means that for a 1 unit increase in working hours, 1 unit working hour we increase could predict value of salary to increase by 243.714 units. Okay, so after that we are talking about the significant value. So the p value, okay, the p value that has been associated with this is hours, yeah, with with hours variable, okay, is just now is how much? 0.002, okay, is 0.002, in which p is less than 0.05, okay, and you are saying that if less than 0.05, the null hypothesis is rejected. So means there is what, significant, okay, significant for the hours variable. So this indicates that the hours variable is significant yeah, is significant. So if it is significant, we can say that we have sufficient, okay, sufficient evidence, and there is and uh, there is a sufficient evidence, okay, to support or to suggest that the hours have a significant effect on salary. Okay, so that is how you report on the beta. Okay, report on the beta value. All right. Okay, so you have interpret for both the values for the age and hours. Right. So done. Right now we are going to the uh this is the last question. Yes, this is the last question. Based on the SPSS output table above just now, you have two tables, ANOVA and the coefficient. Test at alpha 0.005. Sorry, 0.05. Okay, they are giving you the alpha at 0.05. So whether the model is suitable to determine the Y annual salary. Okay, so they are asking you whether if you use the test, the linear regression test at alpha 0.05, whether the model is suitable or not, okay, to determine the salary. So if yes or no, you need to show all the steps in hypothesis testing. Okay, hypothesis testing meaning from the um, from the very beginning that you state the hypothesis until you decide you want to uh, suggest that it is significant or not. Okay, so how it will involve with several steps. Okay, for the first steps, okay, we have several steps. So I just do inform of the steps. So afterwards, if this kind of question, okay, this not really 100%, but if this kind of question that will come up in your final exam, you try to answer in steps so that uh, your examiner, okay, so that your examiner will read all of the answer easier. Okay, so you will get high marks lah. All right, so try to answer in a step. If you want to make it in a paragraph, it is up to you, is actually. But if you do it in steps 1, step 2, step 3, then um, it is easier for the examiner to marks your paper. Okay, so step 1, sorry, step 1. Okay, step 1 is, okay, state your first step. Your first step is you try to state the hypothesis. Okay, remember, if you state your hypothesis, you need to state your null and alternative hypothesis. Okay, so your null hypothesis, HO is null hypothesis, H1 is alternative hypothesis. Okay, all the things, all the information actually you already have in your table here. Okay, you have no problem because you know already your IV and your DV. Okay, so the first step here, what you need to do is, based on the question they ask you, is it the model is suitable or not? Okay, so this is the key point that you need to use. Okay, So the first one, we are saying that the model, okay, is not suitable. This is for null, for determine the annual salary. Okay, so second one is alternative hypothesis. The model is suitable for determine the annual salary. Okay, so this is your alternative hypothesis. Done with the first step. Second step. Okay. Second step, you need to state that your significant level has been set. So you need to set the significant level. Okay, you need to set your significant level. Your significant level is here. Okay, so just write the significant level, okay, which is alpha. Sorry, this is alias, which is alpha. Okay, is what happened? Is given 0.05. Okay, based on the questions. Now, step 3. Okay, all right. Step 3, you need to do the statistic. You need to you need to discuss about the test statistic. So compute the test statistic. Okay, so what you need to do is you look at the F value. Alright, so you need to look at the ANOVA table at the F value. Your F value, your F statistics, 8.363. Okay, remember again, this is regression, right? So state your F value. Okay. Actually, for this question, you don't need to go to SPSS and try to run your SPSS. No, because you already have your output just now. You already have your output, and then you just discuss, pretending that you are the one who run the SPSS. You are the one who obtained the output for the SPSS, and this is time for you to discuss. Okay, so just pretending that you are the one who run the SPSS. So how? From the SPSS output, okay, the F value for what model? Regression model, okay, is 8.363. Okay, this one is from the table just now. Right, you just state what value and what test, what value that you want to discuss about. Okay, it is all about pretending actually. Okay, you pretend that you are the one who do the SPSS output, and this is all the steps you have done. And then you just try to discuss back in the question. Okay, although you know that you are not the one who run the SPSS, I know. Okay, but it's just that the examiner want to test your understanding, whether you know how to do step by step. Okay, step 4. Okay, for step 4, you need to determine the critical value. Okay, if you still remember in my lecture for regression, okay, linear regression, I have point out some critical values that you need to know in linear regression. So for this one, you need to determine the critical value. Okay, so all right. So uh, your F value, okay, your critical F value is corresponding to the significant level of 0.05. Okay, alpha 0.05 with the degree of freedom is 2. Okay, 2 for the regression and 12 for the residual. Okay, all right. So 2 for regression and 12 for residual. The degree of freedom. DF here is the degree of freedom. So you need to state. First is what value for the F critical. Okay, and then what significant level 0.05, and then your degree of freedom 2 for regression, 12 for residual.